You're listening to Don't Waste Water.
The enemy for us is time. The clock is ticking. 2030 is coming up. Climate change is taking over in waves all the time and reducing our sort of leverage. So instead of painting one industry or one, let's say, company as the villain, we need to work together against the real villain, which is the clock.
Hello, bonjour, and welcome to the Don't Waste Water podcast.
Post 2022 June, we have people coming a bit like a headless chicken saying, hey, all our solutions to date are becoming redundant. We can't remove PFAS to this level. It doesn't work. We can't even do it for a month. And so in that, it feels more like firefighting. We're saying, okay, let's talk about where you can fit in our waiting list for installations.
I'm your host, Antoine Walter, and in today's episode, I'm excited to welcome back Henrik Hagemann as my guest.
We know PFAS is essential for making stuff. It's a super chemistry. You can use it to make mRNA vaccines, to make semiconductors for EV cars, and for the semiconductors in your phones.
Henrik is the CEO and co-founder of Puraffinity.
Compared to 2016, the EPA went out June 15 and said PFOA is 17,000 times more toxic than they thought. And that's 100,000 times more toxic than they thought in 2009.
Puraffinity is a GreenTech company that designs smart materials for environmental applications. And as you may have discovered by Season 4, Episode 1, they strive to solve the daunting PFAS/forever chemicals challenge we face. We all have PFAS in our blood, and this for quite a simple reason. Forever chemicals are everywhere around us. For the better, and let's face it, often the worse, we use PFAS in so many parts of our daily lives that it would be almost impossible to ban them. This wouldn't be much of a problem if they weren't that toxic. I know. Thank you, Captain Obvious. Yet, PFAS also confronts the water sector with a complex equation to solve. On the one hand, we'd like to protect everyone from toxic substances, and with the advancement of technology, we can. But on the other hand, doing so is still prohibitively expensive today if we were to do it on a large scale. Sure, promising new ways might change the name of the game. We've, for instance, discussed on that microphone how supercritical water oxidation could eliminate PFAS, and everything else theoretically in an even energy-positive fashion. But we're still far from the large scale today. Let's pause here for a second and apply some advice we heard here a while ago from Claudia Winkler and Alice Schmidt. Let's zoom out before we zoom in. We need PFAS in so many of the products we use, so we produce PFAS. And then we realize more and more how dangerous they are, so we destroy PFAS. And the cycle goes on. Don't you think there may be a better way? Well, that's what we'll explore today with Henrik, and he'll do that much better than me, so I won't spoil you with what he explains so well. I'll let you buckle up for a fascinating 360-degree update on PFAS, where we discuss regulations, recycling, new treatments and their limits, perspectives, and even Erin Brockovich. And remember, if you like what you hear, please share that episode around you. Send it to a friend, a colleague, or your LinkedIn network. Come on, do it, and I'll meet you on the other side.
You're listening to Don't Waste Water, the podcast that helps water professionals to improve their wastewater treatment, optimize their operation costs, and keep up with the latest market trends. This podcast is brought to you by GF Piping Systems. As a leading supplier of piping systems made of plastics and metal, GF Piping Systems is the global expert for the safe and reliable transportation of water, chemicals, and gas. For more information, visit gfps.com.
Hi, Henrik. Welcome back to the show.
Hi, Antoine. Good to see you.
I'm really looking forward to having that discussion with you because you are the best expert I know about PFAS. There's a lot that moved in that PFAS scene, and I think you've been involved in some of these moves. So there's really a lot on our plate for today. And I'd like to start by just refreshing everyone on what Puraffinity, your company, has been doing since the last time you were on that microphone, which was by Season 4 of this podcast. We're now by Season 7. And if I'm right, you got a grant from £1.5 million, which you probably used to make some clever stuff. And I was wondering, what's that stuff about?
So you're stepping right into it, which I love about you, Antoine. The grant was really focused on something called transforming foundational industries. It's jargon, but basically it's telling the sort of UK ecosystem that we need to help the manufacturing industry, the manufacturing sector, get onto the net zero path without adding a massive burden of like additional greenhouse gas emissions from going on to remove some of the things, for example, from their wastewater, improving their processes. And so we had 5 investor partners across the UK selected for this program. One of those 5 was Heritage Group Ventures. So it's the only US-based investor partner. I think they had something like 300 people up for the application. And Heritage Group Ventures is our existing investor. So they were basically saying, hey, we're sort of doing this for you. We think there could be a really good fit. And from the Innovate UK side, we kept getting these requests about, okay, we know PFAS is essential for making stuff. It's a super chemistry. You can use it to make mRNA vaccines, to make semiconductors for EV cars, and for the semiconductors in your phones. And believe it or not, we still do some manufacturing in the UK. We have some flexible, cool logistics, for example, semiconductors, which is going on here. And so we basically set out to remove PFAS from manufacturing plants that use it within their manufacturing. So it doesn't end up in the final product, but doing it without adding a massive greenhouse gas footprint. So for the 18 months program, which we started in January, we basically wanted to, one, demonstrate that you can save carbon footprint by using a sustainable production method. So we've now got some initial data, preliminary life cycle assessment to say something like 60% reduction in CO2 emissions by using a sustainable material like ours rather than activated carbon or ion exchange. And then the other key thing here is we're trying to really rethink the unit economics of PFAS. In news right now, we're hearing a lot about the American wastewater works saying the price of PFAS removal is 100-fold higher with these new concentrations. What are we going to do? And rather than accepting the status quo, which is basically like you and I know that it will be prohibitively expensive for the bulk of utility, for the bulk of treatment suppliers to introduce it if we just use the same technologies. And so we're trying to do what SpaceX did for rockets. They basically reuse rockets across several cycles as their main innovation. That's the feature which drives down the cost. And I see, from a bottom-up perspective, a massive benefit from reusing PFAS-targeted adsorbents. The grant, the 18-month project there, is focused on getting industrially relevant, regenerable adsorbents. We've developed this for groundwater remediation, for drinking water before, but we all know that the water spec is very different for industrial water. It is not usually as sort of neat and simple as a groundwater source. And so the grant is focused on taking that to the next level and really working with the foundational manufacturing industries.
You said 18 months. When will you be done with that part of the program?
So we're 9 months in. So we're actually halfway. I'm just sort of teasing today because my business development manager told me these are the things you cannot say and these are the things you can say. But for the 9 months in, we have already seen some really promising data on broad spectrum PFAS removal. So including everything from PFBS to PFNA. And there may or may not be something coming about those results.
Okay, so let's focus for now on what you can be sharing. And you teased a bit in what you just said. I just noted what you said about the American Wastewater Association, which said that the cost would be multiplied by 100. Let's go into the depth of that in a minute, if you will. You also explain how the SpaceX approach, usually people refer to Tesla, so you refer to the other baby from Elon Musk, but that's also something I like to get to know. And for people which wouldn't have listened yet, which is a shame, on our first discussion, you said sustainable like ours, talking of your material. Can you just recall in just a couple of sentences what you're doing at Puraffinity?
It's very simple, actually. It's been the same since 2015. It's based on 2 key insights. One is we benefit a lot from these precision tools in medicine. We have biomarkers detection, we can do therapeutics, we can capture things that are cancer related very elegantly. We were part of this very big science competition. At the time, it was the world's largest synthetic biology competition. And we basically presented this early thesis to have a targeted material, cellulose-based, which can have specific small binding motifs. So they can be peptides, they can be peptide mimics, they can be proteins that basically target these specific contaminants with an adsorption and ion exchange binding mechanism. So it's all to say, if you can have a precision material, you can get benefits of higher throughput. That was one. And then the second thesis was, we went and talked to the customers, so the real wastewater users, and they all just kept asking us, what are you going to do with this when you've captured PFAS, when you've captured X thing? That's the real issue. How do you do full disposal? And so we developed a safe engineered end-of-life approach, where we basically engineer the material to be reusable. It's a regeneration step which doesn't require a solvent or an alcohol. So it's a more environmentally friendly regeneration step. And then we're trying to prove that in the next generation of products as a way to drive down the cost, the unit cost. So Puraffinity is basically a material development company. We have a predictive capability to respond to regulations. We're always monitoring what's coming next. Is it going to be 4,000 PFAS species? Wow, that's a great broad suite. We can use our predictive material development capability to address those.
So I think last time we discussed, I called them Pac-Man, which was my oversimplification of it. So if you want to hear me rant about Pac-Man, that's back in season 4. I noted some new keywords in what you said, the safe engineered end of life, because the no solvent, no alcohol is probably something we want to discuss as well in a minute in the deep dive. But right before, I'd like to come to the genesis of that sequel, which was you contacted me end of August and said, hey, have you seen what just happened about PFAS? And I have to be honest, at that time, I had not seen all of that. And so I started looking at what has moved into that space. And it's true that end of August was pretty dense in news, because it started with the US EPA, which proposed to take 2 PFAS and said those are now hazardous. So it means quite a lot of consequences if you look at what the press was saying, if you look at how utilities reacted to that. But I won't jump into my conclusions. I'd like to hear your opinion on that. So what did that new regulation change?
I mean, that was a watershed moment. I woke up this day and I knew we had some material out for third-party validation in the US, and I knew they were supposed to come back with an answer soon. And we'll have something, I can't say too much, but one of the items which was really a jeopardy for the last 5 years in the whole US water sort of regulatory environment is this strange compound called Gen X. And it sounds a bit like a supervillain, you know? And everybody was guessing, what was the level going to be? Was it even going to be included? Obviously, Reagan, the EPA administrator, come out and said, we have this big plan, the PFAS action plan. But people have said that before, nothing has changed. And so this time we were just resting on our laurels, or the field was. But one of the things we were testing this material for, that we had shipped out, was Gen X. And so on the same morning, you just imagine me waking up. One, I get data in to show we have like significantly improved Gen X removal with this new adsorbent. And 2, the same day, I read the news, which are very hard to fathom from the EPA. Basically, they've included PFAS species called Gen X in the new regulations, but beyond that, they have changed the stringency level significantly, blowing everything out of the water. No pun intended. So what they've done is, compared to 2016, the EPA went out June 15th and said PFOA is 17,000 times more toxic than they thought. And that's 100,000 times more toxic than they thought in 2009. So not only is this a watershed moment for PFAS, it's the biggest change we've seen in the last 6 years for any contaminant in water. Obviously, that's sort of mind-boggling as it is. I sort of try to bring this to life with my team, but it just means we have to introduce a whole new word to PFAS. Before we knew about trillion, well, you feel like you know about trillion. Now we have to talk about the Q. What's the Q? It's a quadrillion.
Parts per quadrillion concentrations.
Yeah, it's massive. So it's 4 parts per quadrillion for P4. It's 20 parts per quadrillion for PFAS. Basically, they're saying this is not safe at any level. But it's a big deal. The EWG was just saying 1 part per trillion as a safe level. This is an order of magnitude beyond that. So it's completely unheard of that the regulator, even though it's just a health advisory level, is more stringent than this sort of action body who has been advocating for PFAS for years. But the big news, basically, when I was sitting there was, what? They've included Gen X? they've included at 10 parts per trillion. Mind you, this is something that in North Carolina, because of their spill at Cape River, they've had 900 parts per trillion in the drinking water for years because Gen X was supposed to be safe. And so this could be a really significant driver. And it's short chain, which is also a new thing.
Let me just try to get that one. So you mean that Gen X was at 900 parts per trillion, arguably safely in drinking water so far in North Carolina, and now the recommendation from the EPA is 10 parts per trillion. So basically you have to divide it by 90.
Yeah, which is, obviously we can talk about this, but there are some of these overlooked communities where certain PFAS species have been making their way through existing treatment works. And people would be like, oh, it's okay, the carbon doesn't remove short chain like Gen X because they're safe. The only reason we thought they were safe is because we hadn't studied them yet. And so going back to our previous conversation, when I sat with my team in 2016 and we saw the lawsuit settlement for DuPont, this big plant, we said, but hey, it's the carbon fluoride bond, this super chemistry, which is introducing the risk of toxicity. And so we just gambled. We said, I think all of them are going to be regulated and we're going to be developing an adsorbent platform for all of them. But it was a big risk, honestly. We didn't know if they were going to be regulated. So I think that was a huge deal. And I talked to some of the people who provide current solutions, and they're sort of asking, what happens to our carbon now? Like, is it not going to be able to remove Gen X to 10 parts per trillion? Because it was never engineered to do that. It's in that strange sweet spot in between ion exchange, which is super, like it's ions, like super short chain. Ion exchange can usually do. And then very long chain, which usually activated carbon can do somewhat. But in between that, we have the sort of Gen X equivalent. And the EPA moving into that space is a sort of hot potato.
But what are the consequences for the utilities? Because when we discussed about the DuPont case, the case at the time was you're a big industrial and you're releasing PFAS, you have a liability. So you have to deal with your liability. And if I got it right, now at those levels, every single small utility could enter into that liability sphere, because if now the other ones which are supplying water, which is above those thresholds, they could be held responsible for something which is potentially a hazard. Is it that straightforward?
You're touching exactly on where the pain point is. How can we, like with the Superfund approach, where EPA lawyers are pushing for the polluter to pay, the polluter pays principle, how can we put any burden on the wastewater utility or the water utilities to handle PFAS? None of those have introduced it. They haven't benefited from the profits of, let's say, doing Scotchgard or Gore-Tex or Teflon products. There's been significant revenue driven through some of these big industrial conglomerates. And so what it means is it becomes a bit tricky. It's a sort of political hot potato right now with the American wastewater works stepping into it. To the kudos of the US ecosystem, the Superfund has moved as well. The Superfund is moving, looking at PFAS, and they're saying, okay, this could become a designated hazardous substance, where you and I both know.
We should just maybe explain what the Superfund is. So that is one part of the Biden infrastructure bill, but which is dedicated to PFAS with a 1 billion pocket, which could go up to 5 billion pockets in the future, and which was meant to be supporting the smaller communities, smaller utilities to treat out their PFAS.
You have some really good advocate groups in the US. Like, let's say you have the Aaron Brockovich writing about this and supporting some of those small groups. But it is still a massive undertaking. I think often it's easy to forget what the US infrastructure actually looks like for water treatment. Like, there's 35 million Americans that receive their tap water from privately owned for-profit utilities. And we just sort of forget about some of these things. The other part is 10% of the US population have private wells. How are they going to install solutions to remove PFAS when there is a lack of guidance? You have the EWG, you go onto the website. Right now, the EWG is mostly advising for the old NSF standard, which is just PFOS and PFOA. And so right now, things are shifting. It's like, oh, the NSF is changing the NSF standard to include this broad spectrum removal. That's going to mean a massive impact for the consumer. They're going to have to learn about these new things. And honestly, with the issues we have going on, like many of these people, they don't want to learn about water treatment. I think it's in your podcast name. Don't waste water. Like, people don't want to know about safe water. They just want it to be there. They just want it to be something that's provided.
But to get the full consequences of that step change, I've read articles about small utilities that said, we were already debating if we have to stay in the business as a utility, don't we maybe need to transfer into a bigger body to consolidate, to have a broader aspect, and maybe on that consolidated bigger scale, maybe we can afford to have someone who looks specifically into PFAS, and then we are safe, or we cover the risk, or at least we mitigate the risk. And there are even some utilities which already went further and said, that's it, we are consolidating. I've seen articles in the Boston area, some others in the Midwest. And the American water scene is quite special. It's not the UK with its 13 utilities. It's really, there's 90,000 utilities on the scale of the country. So that could be also a step change when it comes to this geography or topography of those utilities. Does this EPA change on PFAS really have the potential to just turn the sector on its head?
It's such a big area, the utilities alone. And I'm happy to say I'm not the expert. You have the sort of George Hawkins, former DC Water, go out and talk about how to consolidate things or how to do it better. And they're trying to do this sort of cooperative approach where they try and bring in different stakeholders, different water utilities to really support one another. Like, you're often going through the same questions and the same optimization pieces. I think that's something which would be powerful. I'm happy to say I'm not an expert on that. I think they will take a village to address many of these things. And I think it's going to take a while. Let's say, as an example, American Water or DC Water, they take a new PFAS treatment technology. They need to go through 12, 18 months of testing before they can then put a business case forward. And that business case can get possibly approved or need some minor corrections. That takes a while. So I think, honestly, it's probably going to take 2-3 years. This is me crystal ball gazing, so it's guesswork, right? But 2-3 years before the utility sector really could have, let's say, an alternative technology to putting in a sort of firefighting reverse osmosis plant, or an ion exchange and a GAC, where you just concentrate the liability and it goes to a landfill leachate. It's not just the cost which is going up. If we're going to be removing PFAS to this higher level, there's an infrastructure bottleneck. We do not, in the US, have any new permits, environmental permits, that have been approved for PFAS destruction for these plasma incinerators since the 1980s. That came in through the sort of environmental initiative from Barack Obama administration. And right now they're saying, actually these incinerators sometimes don't fully defluorinate PFAS. And so they're unlikely to introduce new infrastructure to destroy it. And even with all the cool new destruction technology, there'll be a massive warehouse which would need to be filled with these materials. Even if the money is there and the intention is there, it becomes a logistical bottleneck.
You open an interesting door with this trendy new ways to destroy PFAS, because actually there was a paper by Brittany Trang, which was published in Science, which was since then republished a bit everywhere, because a lot of people saw a lot of hope in that research they did with her team, and they found a weak spot. I'm going to use layman terms in PFAS. Like, you have this long chain of PFAS, and basically there's the head and the tail, and somehow there's a weak spot between the head and the tail, and if you cut off the head, then everything else falls apart. Mm-hmm. And if I'm right, they use DMSO soup and they heat it and they just stir it and the head falls apart. So drop the mic, problem solved, right?
Yeah, I think it's a beautiful initiative in terms of selective adsorption. I told you that beforehand. And I think we have a tendency to sensationalize whenever there is a PFAS progress point, technology or solution. It just reads best in a sensational way. And so I think they did some good science communication about the paper. I love the Twitter thread from one of them, one of the authors behind it. But I think Melanie Benesh, was it? Yeah, I'll add my 2 cents. So let's go through it. One, you're right. It is exploiting this weakness. And so ultimately it's going to benefit selective adsorbents, which can provide a soup of PFAS, which could go into the DMSO destruction path. But let's be real about a few things. One, there is no LCMS in the final material. So there might still be higher than 20 PBT in the final PFAS. We don't know. 2, it hasn't done very well for short chain carboxylic acids, PFCAs. There was lower efficiency on that. 3, and this is the real one. You need to cook the PFAS for 5 days with a solvent. TMSO is still a solvent. So 5 days, this is not an industrially relevant process yet. It's a very good, very, very good mechanism explanation. But it's talking about that gap, that chasm between good scientific breakthrough and industrially scalable solution. We will need to overcome that. And then sulfonic acids, the sort of elephant in the room. It still hasn't done sulfonic acid, PFSAs. It only does half of the PFAS treatment. And then the last point, my sort of commentary is, it still doesn't do point of use or point of entry treatment. Like there, you cannot wait days for the process to provide you safe water. So I think, yes, we should encourage these new developments. We should put it on the front page, but we should go and listen to the scientists and go and see what their science communication says about this sort of paper.
So for the layman like me, PFAS doesn't break the fog every day. And when you see such a hype around the paper, it gets at least people and eyeballs drawn on the topic. So that is incredibly positive. Is there some new understanding about the way to destroy PFAS in that research? Is there something which can be leveraged for the future approaches?
Oh, yes. I think so. I think there is a massive drive towards having, and this is really the one problem statement for PFAS. We need to sustainably capture PFAS as cost effectively as possible. And so this type of selective destruction opens up a much more elegant way of destroying and breaking down PFAS. It's still very much stuck in this paradigm of let's get rid of it or burn it with fire. I mean, that's what we used to do. But now it's like, okay, let's break it down with very intelligent mechanism understanding, which is great. But you're sort of missing a bit of the point. Like the refrigerators we use, they use a PFAS-based chemistry, the refrigerator fluid, and there's an infrastructure in place for reusing that because it's valuable, and refrigerators work with a lower carbon footprint when they use the super chemistry. Of course, you can use something else, but it won't be as efficient if you don't use a PFAS-based chemistry. And so they've built an infrastructure to reuse it, capture it, circular economy. Now, it doesn't work perfectly all the time, but that approach, that paradigm, will save us a lot of trouble in terms of we only have a couple of billion tons of CO2 budget left. And if we're going to be creating like novel PFAS chemistries, destroy them, creating novel ones, it's a lot of that budget which is just going to waste. And so I think it's good. Phase 1, let's do destruction. Let's take care of it. But phase 2, let's focus on making a circular process.
What's missing today to really go into that realm of circular economy when it comes to this PFAS? There are 14,000 substances. Meanwhile, maybe you cannot have a circular loop for all of the 14,000, but maybe for the most important ones. Sounds about logical and going together with the sustainable times we should be living. We shouldn't just do kind of that stupid thing of creating, destroying. That's not a useful cycle. So technically speaking, how far are we from being able to recycle PFAS?
It's one of those great initiatives where you have Ellen MacArthur Foundation and others try and bring together stakeholders. So large chemical companies, new solution providers, government, etc., to look at, okay, what's missing for us to just have a first use case beyond refrigerators. So between you and me, there is a use case for PFAS to be reused. But for a first one, which comes from the wastewater cycle, what's missing? I think there's a few pieces that's missing. When we did microplastics, you remember there was that whole fuss. Plastics, awful, what are we going to do? And what they did was they brought together coalitions that worked together, multi-stakeholder, and they found some lower grade plastic use, like your bin bag. You and I's bin bag doesn't have to be the best plastic. It can just be a tier 2 or tier 3 plastic. And so it became a lower grade application for plastic where you could put all the recycled plastic as an example. That sort of thinking is what we need to bring into PFAS. You have hundreds of products that need PFAS. Everything from you go to the shower, your chrome plating of the shower head or the sink, that's using PFAS. There's actually quite a low grade of PFAS. You don't need the most specific sort for that. Similarly, with some cement manufacturing, they sometimes use PFAS chemistries for the production of that. Again, doesn't have to be the highest grade of PFAS. what we need is infrastructure. We need a coalition towards this, and we need to bring together stakeholders. I try and remind my team about this. Like, the enemy for us is time. The clock is ticking. 2030 is coming up. Climate change is taking over in waves all the time and reducing our sort of leverage. And so instead of painting one industry or one, let's say, company as the villain, we need to work together against the real villain, which is the clock.
You mentioned this importance of coming together and putting the right resources and synergizing those efforts. I'm coming back to what you said about the American Wastewater Association, who underlines that eliminating those PFAS is going to be very expensive. Is that the kind of awakening that you need to see everywhere, that we say, wait, just saying it's dangerous and destroying PFAS isn't going to be the sustainable solution because no one wants to pay for that?
Yeah, I think it helps in one way. It helps to say it would be too expensive to use existing PFAS treatment technologies. It would cost us $370 billion just for PFAS. It makes no sense. I think then it's a question of the so what. Try not to end up in like doom scrolling where you just read about all the wildfires. You want to then say, okay, what tools do we have? What first principles can we apply that will change this? One could be this sort of new selective destruction method. That could be part of the toolbox. So could be a circular destruction method. So you have the supercritical water oxidation, like Aqua Arden 374 water, where basically they fully defluorinate the bond, and they break it down into fluoride, carbon, some water. You probably use some of the gas, and it can, with a heat recovery pump, pay off some of its high energy consumption. Those tools, alongside obviously like capture and concentrate steps that probably you want to reuse to save cost, that we can bring together. We're not trying to stir up more attention on PFAS. We're trying to use that, funnel it in to get some action, to get some jealousy cases going.
It is still a challenge to get everyone to understand what we're discussing, because when you bring up PFAS in the US, it's the EPA communication. In Europe, it's going to be the REACH approach. For really the man in the street, where I would say I belong on that topic, it's really, you do know that there are thousands or hundreds, thousands even with REACH of those substances, and you're like, oh, bad chemical industry, let's destroy everything. So I think it's important to convey that message that PFAS is in our daily lives, it's in our blood, that's what we know, but it's also a positive things. You mentioned the shower, we have it in a lot of objects, and then you can debate, is it the right thing or not to use it? But if already we are accustomed to use it, maybe it's about bringing this element of resource recovery to make it more sustainable. But where I'm heading with that is that I've seen also in that list of regulations from the EPA that they listed 12 PFAS that they want to remove as authorized substances, so would be forbidden. And when you read that, it's like, okay, 12 out of 4,000, and so what? Plus, when you read the announcement, they also mentioned that those 12 substances are not in use anymore anyways. So I just don't get it. What's the message when you share these kind of things, like those 12 are out of the game? Okay. And what should I, as a layman, understand?
If I could give you the layman, like I'll meet you on the street explanation, I would say there's a big diamond. Imagine this big iceberg. And at the very tip of it, we have poking out of the water, maybe 2 out of 5,000. If you go just below that water, you have 12. They're just surfacing out of this large ocean. And those 12 are the ones, these forever chemicals, which enable our modern industry, that have just poked out onto the EPA radar. If you look underneath this, there's 5,000, there's 12,000 species. And these are not things we can easily get rid of. They have super properties that enable us to make vaccines. So they're used in mRNA vaccine manufacturing. They make EV chips. So you can't have a sustainable car without using PFAS. And spacesuits. We can't go to space without a PFAS-based chemistry. And so the impact, the so what, is basically EPA is doing good stuff here, but they're missing a bit of what the Europeans have actually paid attention to already. So this is where it gets a bit of tension going. The Europeans at the European Commission very bravely went out and said, this needs to be treated like a class. So they take this iceberg, they lift it to the surface, and they say, hey, there's 5,000, there's 12,000, all of those within the next 5 years need to be removed. Otherwise, it will not be classified as safe. And what they said, and they recognized, is we're missing tools. So they said we need good analytical techniques for broad detection of PFAS, we need something called oxidizable precursors, which is jargon, basically something that's broad spectrum, looking at all the PFAS, all of these little bonds between carbon and fluoride. That move was courageous, and they enacted it into law in 2021. Is the US going to move on that? I mean, there are lots of finger pointing towards maybe they should. I think already starting with 12, you're going to see a big shift. And for better or worse, it's only the beginning. So I like to say it's a brewing storm. There's still more to come, even though it feels like, holy cow, this is the peak of the PFAS hype cycle. Actually, there is more to come.
That's maybe the peak of the PFAS hype cycle in the US, but what about Europe? You mentioned how Europe is forward-looking when it comes to PFAS. If you had to synthesize it in a couple of sentences, what makes that European approach so special?
It's very simple. We have 20 PFAS species in the 2020 Water Framework Directive, which have been identified as needing regulation. So those 20 PFAS species, they are basically coming into law over the next 3 years. Then what they say is by 2025, they want the whole class of PFAS species to be detectable. Probably they're going to use total oxidizable precursor assay, TOPA, or total organic fluorine for detection. When I talk to the EPAs and the local sort of jurisdictions within the EU, it sounds like TOPA is the front runner right now, or top assay, whatever you want to call it. Now, the real question for me is, when is it going to have teeth? So you and I, having been in the water space for a while, we know that there's a lot of bodies of water within Europe which are actually not classified as safe right now. I mean, you see the sewage which is being dumped in the UK, and that's like unlawful, supposedly. So I think the real question for me is, when is it going to have teeth? It already has teeth in certain regions. So you have northern Italy, where they used to have legacy PFAS manufacturing. They have 12 PFAS species they need to remove. Otherwise, they get fined, because there are more than 100,000 Italians exposed to unsafe levels of PFAS from that manufacturing plant alone. And so I think it's going to be fragmented. Even though the EU tries to make it like a class and tries to make it unified, it's going to be individual states within countries that are going to be the front runners.
So that means you're probably in a good space and in a good spot with your company. And you've mentioned how some of the technologies which we have been discussing are not yet to this industrialization level. So I'd like to understand a bit how Puraffinity developed as well. You mentioned how you're in that space since 2015. I've seen that you've hired a production director, and that sounds to me like a step forward in your industrialization process. Are you still a research company, or are you now a real industrial company?
It's why I wanted to talk to you. There's still more to come, but beforehand we were bottlenecked by R&D. So we had these 4 different assets for PFAS treatment, but we were bottlenecked by getting this first efficacy data from a third party. It's a bit like when you develop a vaccine. You can only say so much about your own data in-house. You need a third party to say, okay, has this efficacy level to this success criteria? And so where we've gotten to now in the last 2 months for our front runner asset, we basically got third-party validation, which may or may not be the sort of news that could be coming in the next couple of weeks from our side, but it's focused on broad spectrum PFAS removal. So it's not just one site, but actually 3 different sites we have been testing with in the US, coming back and saying, okay, the performance you have for PFAS is what they would classify to the new NSF53 regulations. So their broad spectrum, short chain and long chain, is best in class for the materials they have tested. And they've tested lots at these sites. And so where that takes us, the so what, is we're shifting. We are shifting gears from being bottlenecked by efficacy data, third-party scientific proof, to scale up and manufacturing. And I can bet you, as an engineer, that to me is just, it's really right up my alley. And so we've been building out the industrial manufacturing capability. We are currently sitting at about 5 tons per year production capacity. We're not churning that out like every day, but we've hired this new production director who comes in from Johnson Matthey, comes in from Dow Corning, where he was a project and production director with 30 years of experience to help us get on this scale-up roadmap. It's not just about hitting 5 tons. You and I know, yes, it will do a lot for a point-of-use player, okay? But for an industrial installation, that's just the beginning. you would ask for 5 tons for a small plant. And so we're executing now on a new roadmap, which is getting us to beyond 100 tons of production capacity. And that is really going to enable us to start addressing just some of these front runners issue with PFAS, where it's already regulated, they already have solutions, they're trying to get more sustainable, or they're trying to respond to the new stringency levels. It's not just about 2 PFAS species, it might be about 12.
So when you mention this scale up and different size of what you're addressing, what is your typical persona? What is a typical challenge which you take on as Puraffinity, and what is maybe not sweet spot, which is not the right word, but where do you add the most value within that full spectrum of people which are now concerned by PFAS?
The problem statement for PFAS is where we start. So we spend a lot of effort actually just sitting and listening to possible personas. And they will go on about different issues, whether it's the lead in the pipes or whether it's the PFAS that's coming up as an issue. A typical persona for us has gone through 3 stages. So I like to talk about this maturation curve. Phase 1, you hear about PFAS and you start thinking, oh, is there a litigation that's awaiting me? And so you start internally sampling for PFAS. You're not telling anybody about it. Between you and me, some of the big chemical companies were in that stage for 60 or 50 years. So it can be long. Phase 2, you're sampling and you start reporting to a sort of local enforcer, usually an EPA or some enforcement of some type. And then after a while, they will tell you, okay, it's great. You create your jobs here. Thank you for that. But now you're going to need to install a treatment solution for this. So stage 3, which is our sweet spot, they have been sampling, they have been told to do something, and they have a treatment train for PFAS. Usually they would install a sand filter, a GAC, an ion exchange, and then they would take care of the old regulations of PFAS. So our persona is at that stage. They come and say, oh, actually, my ESG is not very good because every month, for some of these plants, every month, they're replacing the GAC. They're getting a new tank because they have stringent broad spectrum requirements. And 2, they are concerned about what the cost of that. So if we're going to be removing to the new regulations, I'm going to need 3 times more tanks, maybe 5 times more tanks. So it's more of a sort of capital footprint issue rather than whether there is a budget. So at that point, we listen, we try and learn in a consultative way what the issues are. We're not trying to sell a component for a solution. We're trying to understand what the sort of solution should look like. And then in our case, sometimes you can replace one of the tanks where they might have had ion exchange with something like our adsorbent, or sometimes both. And then it's basically providing a total TOTEX solution, which is more cost effective for responding to the new PFAS regulations. That's a typical persona pre-2022 June. Post-2022 June, we have people coming a bit like a headless chicken, saying, hey, all our solutions to date are becoming redundant. We can't remove PFAS to this level. It doesn't work. We can't even do it for a month. And so in that, it feels more like firefighting. We're saying, okay, let's talk about where you can fit in our waiting list for installations, and let's evaluate. Sometimes they have 12, which is the most cost-effective way to remove it. Sometimes they would have 12 media just to remove PFAS, which is nuts. This is in Australia, which is like a front runner. But imagine that, 12 vessels with different adsorbent media just to do PFAS treatment. And sometimes it's simplification. So the engineer in me loves to reduce complexity, fewer tanks, and then, you have the chemical industry where they would like to reduce their carbon footprint because the overall group is asking them to have a lower carbon footprint. Show me your net zero plant. And they sit there as the sort of plant manager. And they're like, I still need to remove PFAS. So for them, it's about regeneration. That's what's driving the conversation.
And what's your business approach for those people? You said you're in for the TOTEX. You're not in for selling the medium, but you still have to sell something. So do you sell the medium to an EPC, which integrates it into those tanks? Or do you retrofit the existing tanks and then it's directly a discussion with the end user? Or what's your business approach?
Puraffinity is entering this fun stage of going to market. We like to partner with organizations. So we would partner with a R&D collaborative partner where basically they might work like an EPC. And we then look at which sites could benefit from having a more high throughput PFAS treatment solution. And then if it fits, we would do some third-party validation. And then following that, we would basically be providing a solution with this EPC or local partner. As you know, it's very fragmented for water treatment. So one state in the US will have a local plumber who does all the installations. One country in Europe will have a local startup who does most of the installations. It really varies. And so we're trying to have the most impact by partnering with organizations. As a company, we have this big moonshot to provide 1 billion people with PFAS safe water by 2030. And there is no way we can touch all those lives by doing the installations ourselves.
Do you also have a roadmap towards 2030 to reach those 1 billion? And are you on track?
Yes, we have a roadmap towards reaching 1 billion. What's beautiful about this thing is if you install at a very high throughput industrial treatment works, touch hundreds of thousands of lives without going to any of their households. You don't need to see them or look them in the eye to benefit. And it's what I find so empowering about the water field. There are all these people who might be indirectly benefiting from the new solutions, and they don't need to know about us. We can just sit there in the background, walk on the street with a big smile on your face because you've touched their health cost, but they won't know it. And so sitting in that data layer and in that tech infrastructure for PFAS removal is a big part of our roadmap. We're obviously lucky to have investors that think about that long term. So it's Heritage Group is one, but also Kindred Capital and Verve Partners. Some of those, they take a much longer view, but they want to see the impact from the sort of new groundbreaking scientific breakthrough.
So you mentioned your crystal ball at the beginning of that discussion. And if you look now in that crystal ball, what's happening in the next 2 years for PFAS in general and for Puraffinity in particular? What do you see? What are your predictions?
Yeah, it's so interesting what's in the next 2 years alone. So in the next 2 years, and we're seeing it right now on the ground, there's this saying, it's like slowly, then all at once. And I think that's what the cracks are starting to show for PFAS, first of all, but also for the sort of legacy infrastructure, the water infrastructure, which is really like, it is starting to flow through. So you have Jackson, Mississippi right now, 100,000 people, they're queuing to get water. They're still under this sort of boil water instruction. And those might seem like cracks right now. But as you start adding those up, I think there's a real risk of possible civil unrest around water security, whether that's in the US or other countries. That's something that's sort of keeping me up at night. And like, that's the real enemy for this field. What's in the next 2 years for Puraffinity? For us, it's about scaling up to meet this challenge. So if things go well, we will meet in a year's time, hopefully before, and hopefully in Singapore, where we will say, okay, we're now turning out 100 tons of material a year, 200 tons of material a year, and that's directly impacting these people in terms of removing and eliminating PFAS. So it's going from being an R&D company to being a commercially facing entity with real production. That would be a massive shift. The field itself is going to be going very bumpy, I think. We have in the next 3 months a supposed plan from the EPA about PFAS. It's not going to be a linear path. You're going to have states that fight back. You're going to have states that push really fast forward and say, oh, are they going to try to do it as a class? That would be crazy. And then, we see one another, Antoine, and I think we will both be retired before there are some of the states in the US that will do anything else than PFOS and PFOA. They'll just be doing the long chain. And if you go to their state, those are the conditions. I don't think it's an easy journey for the EPA to try and standardize a union that's already sort of breaking up at some of the seams. So I think those macro trends are going to be impacting even something as simple as PFAS.
The good news which I pick up in what you explain is that there is still a lot which is going to move over the next month and years, which will give us the occasion to do a sequel of the sequel. And if it's as fascinating as that one, I'm looking forward to that sequel of the sequel. So, Henrik, it's been a pleasure to explore that field again with you today. And if that's fine with you, I'd like to round that off with a new set of rapid-fire questions, which is not exactly the same than the one you had last time.
Nice. Yeah, that sounds great. I love the rapid fire.
It's time for the rapid fire questions.
So the rules are still the same. I try to keep the questions short, and you have to keep the answers quite short, and you'll see that I'm the one sidetracking. So my first question is, what is the most exciting project you've been working on, and why?
It's introducing regeneration for PFAS because it changes the cost entirely. It could reduce the cost by 80%, and it makes it sustainable, which would be fascinating.
Can you name one thing that you've learned the hard way?
Oh, yes, I definitely can. One recent thing, so I'll put it very recently, is when you get married, then even if you both work in the same field, my wife works in the water field, then you cannot talk about water all the time. You have to take some time to talk about something else, even if you're only thinking about PFAS and like how we're going to address these inequality.
I know the feeling. Not with my wife. My wife is not in the water sphere, but both my parents are water engineers, so definitely I get the feeling. What is the trend to watch out for in the water sector?
I think it's simple. I mean, it's simple but hard to do. Decentralization, digitization, and then the third one is the circular economy. If you can hit those three tailwinds with your technology, then you're in a very rapidly moving river. The one thing I would look out for beyond that, the larger picture, is how can we avoid some of the conditions for civil unrest? How can we look after some of these sort of parts of the community who are low or middle income and ending up sometimes like Jackson, Mississippi? That is just a breeding ground for riots or for inequality or civil unrest. And that is not what we need as a society or as a field.
Hard to switch to the next one after this one, but that's the rule of the rapid fire question, so I have to swipe. Is there something you are doing today in your job that you will not be doing in 10 years?
Oh, that's great. I think there is this saying that when you're a small company, so we're only about 20 people, you work a lot in your business. But I think when you start to grow that and orchestrate the larger organization, you start to work on your business. You start to work on, okay, what's coming next for that business. And I think I love the approach that sort of Bezos takes, where he's saying, okay, if I work on the here and now, I'm getting carried away. He should be looking at 2 years ahead. And that's where the time horizon he should be spending the bulk of his time. I'm excited in 10 years' time to be moving into that. And I would love to get to that stage with the current venture.
And last question, if you were a world political leader, what would be your very first action to influence the fate of the world water challenges?
If I really were in that position, I would invite some of the other leaders for collaboration. And I would pick up the jealousy cases. We've got some beautiful jealousy cases in the water field. And I would say, okay, how can we do it simply? How we can replicate these jealousy cases where they've already demonstrated an amazing sustainability improvement, an amazing improvement in cost of water treatment provision. And then I would work together.
Well, Henrik, it's been a pleasure to discuss with you over this hour. Is there an elephant in the PFAS room that we have missed today?
It's a very good question. I think there is an elephant we're missing. So we have community groups like, let's say, Erin Brockovich, who are paying a lot of attention to this. She wrote a book about it. How do we sort of make these disparate groups meet up without it being confrontational, without it being about this community is currently getting screwed because there is a discharge of a chemical? How can we meet up without that needing to be the occasion? Because if we can, then I think we can tap into a much bigger economy in terms of changing these things, but also a much bigger workforce. There's a lot that could be done if we bring the stakeholders together. And that's a bit of an elephant in the room.
And what's the catalyst which we would need to gather all those people's initiatives together?
I think we need these very strong figures that help to push. You have Erin as one, but who's pushing from the industrial side? Who's the Erin equivalent from the industrial side or from the utility side? I mean, I mentioned George today, George Hawkins, like he's doing stuff, but we need someone as passionate as Erin. She's not getting paid to do it, but if she could meet with the equivalent from these other sectors, then I think we could do more.
Well, then it sounds like something we have to advocate for, watch for, and probably participate in. So if anyone listening to that feels like the passion and the grit to take over that torch, I'd be happy to redirect those people to you and maybe to start a movement. Where shall I redirect them the best?
The best would be to just reach out to me. I'm Henrik at Puraffinity.com. If you've listened this far, you've done well. It's like there's a lot of complexity. The other one is to contact us as a company. We are really keen to learn from people as well as to engage. It's not just about like being a part of a solution. It's about addressing the problem statement. So yeah, email, contact on website and Twitter as well. I'm also on LinkedIn. Feel free to add me.
Awesome. Like always, all those links will be in the show notes. Henrik, it was a renewed pleasure to have you on that microphone. I'm looking forward to the sequel of the sequel, which shall happen at some time in the future. And thanks. Yeah, thanks a lot and talk to you soon.
Thanks so much, Anton.
Thanks for listening to Don't Waste Water. This podcast was brought to you by GF Piping Systems. Loved this episode? Head over to Apple Podcasts to subscribe, rate, and leave a review. See you next time.